Just finished grading your exam 3. Now I'm going to go over, I'm going to make a tutorial for exam 3. The only reason I make this tutorial is to allow you to get 100 in the test. If you don't get 100, that defeats the purpose. I'm going to do it on the exam paper is because I'm a little tired last few hours. I have been grading all those papers. Please make sure that you go over the problem as many times as needed to understand the concept. Tutorial, I'm going to go over exam 3. The problem number 1 requires ruler and a protractor. So you have to construct a displacement. Why is that? Because an ant move x meter to the east, y meter to the north, and again z meter to the east. So this is initial point, this is the final point. The displacement is the shortest distance between the initial point and final point. You connect them. Don't forget to put an arrow. Okay, so now you're going to use the centimeter. Make sure don't use the inches, use the centimeter, because I give you the conversion for centimeter. This is 4 point, this is 5, so this is 4.5, so I say 4.6 centimeters. You do not write 4.6 centimeter here, you're going to write it on the scrap paper. 4.6 centimeters, which is your displacement. I do not want you to give me the displacement in 4.6 centimeter. I want you to give me an SI unit. So you convert this by using the scale that I gave you. Centimeter, centimeter cancel. So 1 centimeter is 7 meters. Centimeter, centimeter cancel. 4.6 times 7. 4.6 times 7. And that is 32. So you're going to write 32 meter over here. That's it. Now you're going to take the protractor and you're going to find the 0 on the protractor. I show you many times, so I'm not going to show you again. Okay. So this is 20. This is 30. This is not in the middle of 20 and 30. So I would say this is 23. So I'm going to go by this is 20, 23. 23 or 24? 23 degree. That takes us to question number 2. We solved question 1. Question 2. Question 2, you have a road, right? On the road, this is kind of an inclined road. The road is 5 meter tall. So this road is 5 meter tall. A car is initial velocity 1 meter per second. And the final velocity is, of course, 4 meter per second. Right? Well, acceleration coming from due to gravity because this is inclined, but you don't need to know that. What is the source of acceleration? I did not ask you that. I asked you to find the acceleration. So how you can find it? Vf square is equal to Vi square plus 280. Vf square is 4 square is equal to Va square is 1 square plus 2 acceleration and d is 5. Okay, so you have 16 1 plus 10a. So 15 is equal to 10a. So a is equal to 1.5. So Vf is equal to Vi plus At. Vf is 4, Vi is 1 plus A is how much? 1.5 and T. So this is 3 is equal to 1.5 T. So T is equal to 2. So the time it takes is 2 seconds. So the time it takes is 2 seconds, right? 2 seconds. So the answer is 2. So you're going to write 2. Number 3. So now you're going to use the scrap paper. Keep using the scrap paper. Okay. So the car is moving with 25 meters per second, right? So the car is, number 3, moving with 25 meters per second, right? This is initial velocity. Final velocity is 0. Final velocity is 0. So that means if the initial velocity is this way, acceleration has to be this way. Otherwise, the car will never stop. From location A to B, the distance is 40 meters. What did I ask you? I asked you to find the acceleration, the magnitude of acceleration. We know the direction. I asked you to find the magnitude of acceleration. So Vf squared is equal to Vi squared plus 280. So this is 0. Vi is 25 squared plus 2. I ask you to find the magnitude of acceleration. D is 40. So acceleration is 25 squared divided by 80, 7.8 meter per second square. And that is option number 7.8, option number 3. You can do both. You can circle this one and you can write 2. You can circle this one, you can write 3. That's easy for me. You have to help me out because I try to finish grading before 11 p.m. or 11:30 p.m. the day you take the test. It is only possible if you make it easy for me. Number 4. Okay, so a brick falls. So I'm going to use the scrap paper again, number 4, from the wrist. Okay, so let's try to understand what's happening. There is a brick, right? It falls from the wrist, meaning that velocity is 0 from a rooftop, I guess, I don't know. Fall from the wrist. So you drop it and it falls here, right? All right, this is location 1, this is location 2. 6 graph possible. So try to understand it graphs as it moves from, as it falls from here to here. So this is dt, this is st, this is absolute value of acceleration t, this is displacement versus time, this is velocity versus time, and this is acceleration versus time. Okay, this has to be like this, this has to be like this, this has to be like this, and this one is like this one is like this, and this one like this. Now let's understand this, why it is this. When you drop something, right, then this is quadratic. When you drop something, it is quadratic, so it must look like this. Why this one look like this? Because d is equal to vit plus half at square. This is 0, so d is equal to negative 5t square. This is negative, so it has to look like this. When you take the absolute value, then this looks like this. Initial velocity is 0 when you drop something. That's why initial velocity is 0 over here. Impact velocity is maximum. Impact velocity is, this initial velocity is 0. Impact velocity is maximum. That's why it is over here, this velocity. When you take the absolute value of this one, you get this one. Acceleration due to gravity is negative 10. When you take the absolute value, you get this one. Okay, so what is the answer then? The answer is over here. So answer is 3. The acceleration is constant. Acceleration is constant. Okay, is the acceleration constant? Yes, acceleration is constant. Speed is constant. Yeah, speed. I'm sorry. Is 3. Acceleration is constant and speed is increasing. Is 3. The speed is not constant, so speed is increasing. You see, speed is increasing. The magnitude of velocity is also increasing. So this two tells us same story, same thing. Speed increasing, magnitude of velocity increasing. So this two tells us same story. This two tells us same story. Why? Acceleration constant. Even you take the absolute value, is constant. Even you take the absolute value, is increasing. Here is increasing. What is increasing? Magnitude of the velocity. Magnitude of the velocity is speed. Okay, I can write over here magnitude of velocity because that's the speed. Okay, that's number 4. Now let's go to number 5. Okay, number 5, what happened? Number 5, the answer is 2. Let's explain why answer is 2. Okay. An object is thrown vertically. So you're going to throw an object vertically, right? This is dyt. With initial velocity 9.8 meter per second. With angle 90 degree. With respect to the ground. Like when you throw like this, the angle is 90 degree with respect to the ground, because you measure the angle with respect to x-axis. When you measure it with respect to x-axis, this is 90 degree as you see it, hopefully. So what are you going to do? Vf square, this velocity is 0. Vf square is equal to vi square plus 2ad. So this is 0. Vi is, what is vi? Vi is 9.8 square plus 2. Acceleration is negative 10 and d. So d is 9.8 square divided by 20. So this is 4.8-ish. So it is 4.8-ish. This one is close to the right answer, so I'm going to choose this one. They probably use 9.8, I use negative 10. They probably use negative 9.8, but I use negative 10 to save the time. And that was problem 5. Now we're going to do problem 6. Problem 6, as I asked you to do this lab, you remember I asked you outside to draw a ruler and you measured how much distance the ruler fall, and that is 2.4 meters. Remember, this is negative because it's falling this direction. It's falling this direction. And the time you measure is 0.71. Okay, now you write d is equal to VAT plus half at squared. Now, when you drop something, right, is negative, but you don't have to write negative. Yeah, it's good to write negative. The initial velocity is 0. Half, you are trying to find the acceleration. The t is 0.71 squared, right? So you get negative 2.4 is equal to this is 0.71 squared is I believe is 0.5. 0.71 squared is 0.5. So half a 0.5. So this is 0.5, which is 0.25. So negative 2.4 is equal to 0.25a. So a is equal to 2.4 divided by 0.25 negative. It doesn't matter because in answer choice I did not give you that option, negative option. So 9.6. Is there any 9.6 for this question? Yeah, 9.5. So 9.5 is closest to the answer. So you're going to choose 9.5. Number 2. Okay, number 7. Option 2. Number 7. Number 7, who is a graph to represent the motion of an object? Okay, so the object is in free fall, right? Near the surface of the moon. On the moon, acceleration due to gravity is 1.6 meter per second square. Okay, or 1 over 6g. Is that 1 over 6g is 1.6? All right, let me see. 9.8 divided by 6. Yeah. Okay. So it's gonna behave same. Okay. What does that mean? I'm gonna show you all 6 graph because it's good to see all 6 graph at the same time. So this is dt, this is st, this is at, or you can say this is absolute value of vt, this is absolute value of at, this is displacement versus time, this is velocity versus time, this is acceleration versus time. Okay, this one is going to look like what? This one the velocity is 0 over here because initial velocity when you drop something is 0, and slope of this one is this one. So slope of this one is this one, slope of this one is this one, absolute value of this one is this one, absolute value of this one is this one, absolute value of this one is this one. Okay, now let's see what happening over here. Problem number 7. Who is a graph to represent object freely falling from the rest on the moon? So they all are distance versus time. So we only look at this one because this is distance versus time. Okay, the distance versus time only can be this one or this one. This one when you don't take the absolute value. This one when you take the absolute value of the displacement. Since they wrote distance they took the absolute value of this one. Okay, very good. So we found the answer number 3. Number 8. Okay, number 8. Now we're going to do number 8. Who is graph best represent relationship between acceleration and time? Okay, so this one is acceleration and time of the near the surface of the earth. Okay, again I'm going to do it again and again and again. Why? Because I don't want you to get this thing wrong. dt, this is s or st or absolute value of vt. This is absolute value of at. This is what? Displacement versus time. This is velocity versus time. This is acceleration versus time, which is g in this case. Okay, so this one is this one is slope of this is this, the slope of this one is this. As I said, when it is a positive curve, the slope is positive diagonal line. When it is positive diagonal line, slope is positive straight line. Okay, because this one is absolute value of this one. Of course, you can do it this way. This one is absolute value of this one. This one is absolute value of this one. This is negative 10, so this must be 10. This is also, you can do this way. This way. This one and this one are the same. Okay, now they are doing only acceleration. So acceleration, no matter what, even if you take the absolute value, is constant. If you don't take the absolute value, is also constant. So number 3 is the only option. Okay. All right, let's use this color. All right, so you are on the rooftop. So you throw something in the air. Your rooftop, this is the ground, and you throw from the rooftop, and let's see what happened. You fail to catch it. Okay, so let's see. Your hand is above this point right here, right? So let's see whether it's going to fall exactly here. It's fall exactly right here. So the x is 0. See, if it fall like this, then the x is now 0. The x is from here to here. Now if it fall like this, then x is 0. You get the idea. Okay, so this is the ground. This is location 1. This is location 2. This is location 3. This is location 4. And this is how many kilometer? Where is this exam? This is 50 meters. So this is 50 meters tall. Your initial velocity is negative 15 meters. Okay, what does that mean? You throw something 90 degree. That means velocity has two components, vx, vy. Vx, you can say v cosine theta and v sine theta. Okay, what is v? V is 15. 15 cosine, what is the angle? 90 degree. V 15 sine 90 degree. So cosine 90 degree is 0. So 15 times 0 is 0. Sine 90 degree is 1. So 15 times 1 is 15. So when I throw something, it did not move to the x direction because all the velocity was acting at the y direction. That's why it did not move to the x direction. Okay, great. So with that out of the way, we're gonna find loss of thing. We're gonna create a table. We're gonna say location. We're gonna say time. We're gonna say dx. We're gonna say dy. We're gonna say I don't know, distance. We're gonna say vx. We're gonna say vy. We're gonna say ax. We're gonna say ay. All right, location 1, which is this. Location 2, which is this. Velocity final is 0 because the ball is turning, changing the direction. Location 3 is this. Location 4 is this. Okay, great. Few things we know. We know ay, negative 10, negative 10, negative 10, negative 10. There is other name for ay, g. We know ax, acceleration due to gravity at the x direction. There is another name for this one, acceleration due to gravity at the x direction, 0, 0, 0, 0. We know vx, if there is no acceleration, then there is no velocity. Why? Because acceleration at the x direction is 0. That's why velocity at the x direction is 0. That's why displacement at the x direction is 0. You see the connection? Since the acceleration at the y direction is not 0, there would be a velocity at the y direction. Since the velocity at the y direction is not 0, then there would be a displacement at the y direction. And of course, at the end, we're going to find the distance. Let's find the time. To find the time is very easy. You can write Vf is equal to Vi plus At, right? Vf is 0 over here, so you write 0. Vi is 15 minus 10t, so t is equal to 1.5. So at location 1, time is 0. At location 2, time is 1.5. So this is double the time because it's symmetric. The acceleration due to gravity is also symmetric. So this must be 3. Now we're going to find the time over here. To find the time over here, you want to write d is equal to Vat plus half At squared. So you want to write this one, negative 50, 15t minus 5t squared. It seems like we don't have to do quadratic formula. 5t squared minus 15t minus 50 is equal to 0. Divide everything by 5. So t squared minus 3t minus 10 is equal to 0. So do the middle term factor, minus 5t plus 3t minus 10. Let's see, 5 times 3 is, well, not 3, this is 2. 5 times 2 is 10, good. 2 minus 5 is minus 3. Okay, so it works out. T is t minus 5 plus 2 t minus 5. So you have t minus 5 is equal to 0, and you have t plus 2. Do you see it? Yeah. T plus 2 is equal to 0. So t is equal to negative 2. This is no good. T is equal to 5. So the time is 5 over here. Great. Now we're going to do, what are we going to do? We're going to do dy. So dy. So let's find the dy. How can we find the dy? Okay, we found the time, so we can find the dy. So the dy over here is very easy. You want to write Vf squared is equal to Vi squared plus 2Ad. This is dy, by the way. So this is Vf squared. The velocity over here is 0. So you're going to write 0. You can 15 squared plus 2 negative 10 and dy. So dy is equal to 15 squared over 20. So 15 squared over 15 squared divided by 20, and that is 15 squared divided by 20, and that is 11.25. So 11.25. So this one is at location 1 is 0, at location 2 is 11.25. Okay, so the dy at location 3 is well, okay, so dy at location 3 is at the distance of the y direction. So this is back to the hand. So this is because this is positive 11.25. This is negative 11.25, right? Okay, so exactly right here is at location 2. This is 0, and this one, the dy is of course negative 50. Okay, at location 4, dy is negative 50. Okay, so now we can find the distance. To find the distance, we have to do this. This. Okay. All right. We're gonna also see whether this is why this is 0 and why this is negative 50. Okay. All right. So now this is Vt, of course Vyt. Now I'm going to draw it. This one is 15. So this is 15. This one is 0. So I'm going to draw 0. This one is negative 15. So I'm going to draw like this. But instead of drawing this, I'm going to draw this one. Okay. This one is how much? We're going to find the velocity over here. So let's find the velocity over here. Velocity over here is Vf is equal to Vi plus At. So velocity over here is vi is 15 minus 10, t is 5. So vf is equal to 15 minus 50. So this is negative 35. So velocity over here is negative 35. Impact velocity is negative 35. Okay. So now I'm going to draw a line like this. I'm going to use the ruler. Okay, I'm going to make the y-axis longer. This is the most important graph. So I'm going to make this one even longer. So this one, how many centimeter like this? This one, how many centimeter? This one is 4 centimeters. So I'm going to make this one 4 centimeters. 4 centimeter. Okay. So 4 centimeter, I'm going to draw this. So I'm going to call this one 1.5. I'm going to call this one 3. And I'm going to make this one 5. At 3 is negative 15. At 5 is negative 35. Okay, so this is negative 15. This is negative 35. This is positive 15. Okay, now area under the graph, this one is half BH. So we're going to verify this, right? You're going to verify this. You're going to verify whether this is right. Okay, so half B is 1.5 and this is 15 and this is hopefully 11.25. So 0.5 times 1.5 times 15 and this is 11.25. So we're going to write 11.25. Now we're going to do this one. Okay, so this is also half a BH. So half B is 3 minus 1.5, so 1.5. H is negative 15. So this must be negative 11.25, right? So this one plus this one is 0. So at 3 second, this one is 0. At 3 second, this one plus this one is 0. At 1.5 second is 11.25. At 1.5 second is 11.25. At 3 second, this is 0. At 4 second, we're going to do this one. We have a rectangle all, which is BH. B is how much? 5 minus 3, 2. H is how much? Negative 15. So negative 30. Okay, so this is negative 30. But why did I write negative 50? Well, it's because at location 4, this is the location 4. It fall from 3 to 4. So I have to include this one. So half a BH. So half B is what? 5 minus 3, 2. This is negative 35 and 15. So negative 20. So 2 to cancel, this is negative 20. So negative 50. And that's how we got negative 50. Now what are you going to do? 11.25 plus absolute value of 11.25 plus absolute value of 30, negative 30 plus absolute value of negative 50. So that's how we're going to write the distance. So this is 11.25 plus 11.25 plus 30 plus 20, and that is 73. So this is 73. So you're going to write 73 over here. Okay, Vy at location 1 is 15. Vy at location 2 is 0. Okay, do you see that? Where is it? 15, 0, negative 15. And over here, negative 35. Negative 35. So we have everything right now. So let's do it. Vx at location 1 is 0. Vx at location 2 Vx is 0. Location 3 Vx is 0. Total distance is 73. Impact velocity negative 35. Average speed, you know the average speed is total distance, where is total distance 73, and total time is 5. So 73 total time is 5. So 73 divided by 5, which is 14.6. 14.6. Area of A1, so area of A1 is 11.25. Area of A3, this is A3 negative 30. Area of A4, A4 is negative 20. Draw the line showing average velocity on the graph. Okay, so the acceleration is constant. Why is that? Because acceleration is g, which is negative 10. So we can use vf plus vi over 2, which is average velocity. So what is vf? Negative 35, right here. What is vi? 15 divided by 2. So negative 20 divided by 2. So negative 10. So you're going to draw a line negative 10. So this is your average velocity. So negative 10. Okay, there you go. All right. So and average velocity is negative 10. Okay, now we're going to do this one. This one is easy. We did it many times, so we should be able to do it. Okay. All right. So now let's see. Let's take some paper. I'll ask you to find the distance at 9 seconds. So where is 9? 9 is between 8 and 10. So where is 8? This is 8. This is 10. So I have 2 points. You know, watch it very carefully. 8 comma 5. This is vertex. Why? Because you can draw a tangent line over here, and the slope of the tangent line is 0. And at 10 comma what? 2. So this is x and y. So your y is equal to a x minus h square plus k. So uy is 2, a x is 10 minus h is 8 square plus k is 5. So this is 2, this is 4a, yeah, this is 4a plus 5. So this is a negative 3 is equal to 4a. So a is equal to negative 3 over 4. Now what are you going to do? Y is equal to a x minus h square plus k. So y is equal to negative 3 over 4. X minus h is what? 8 square plus k. K is how much? K is 5. Okay, great. So this is your equation. So d of t is equal to negative 3 over 4 t minus 8 square plus 5. What time I ask you to do? 9. So minus 3 over 4, 9 minus 8 square plus 5. So d of t is equal to 1 square plus 5. So d of t is equal to negative 3 over 4 plus 5. So you take 4, negative 3, 5 times 4 is 20. So negative 17 over 4. Oh no, just positive 17 over 4. So positive 17 divided by 4, which is 4.25. So 4.25. This is 4.25. Okay, now we're going to do the velocity at 9 seconds. Okay, so velocity, we're going to look at the velocity versus time graph. So in the velocity versus time graph, if this one is, if this one is, how much does this move? From 5 to 2, so negative 3. So negative 3, the area under the curve is negative 3. So area is half BH. So negative 3 half, every interval is 2 second, 10 minus 8 is 2 H. So now velocity is 0 over here. So velocity is 0 over here. This must be negative 3. So look, this is what was going on. If I know the equation of this line, I would be able to find the velocity at 9 seconds, because 9 is between 8 and 10. Okay, so to know that, I know a few things. I know 8, 0, velocity is 8, 0. I know other thing, velocity is at 10-second velocity is -3. Okay, so this is x. Well, I don't need even x, y. So Vf is equal to Vi plus At. Now Vt is equal to Vi. You can use this this equation. At 8 second, velocity is 0. So 0 plus acceleration. What is the acceleration? Okay, let's find the acceleration. This is your x1, this is your y1, this is your x2, this is your y2. y2 minus y1, x2 minus x1. What does that mean? v2 minus v1 over t2 minus t1. Or you can say v final minus v initial over t final minus t initial. They're all the same. They're all going to give you the same thing. So what is v2? Minus 3. What is v1? 10. v1, what is it? 0. And then 10 minus 8 is 2. So acceleration is -3 over 2. So you're going to write -3 over 2 and then the time. Don't forget to write at 8 your velocity is 0. Don't forget to write that. So v of t is equal to -3 over 2t plus 12. So now you can plug that in, 9 seconds. -3 over 2, 9 plus 12. So what do you get? -27 over 2 plus 12. -27 over 2, 27 divided by 2 is -13.5. -13.5 plus 12. So this is -1.5. So this is -1.5. Okay, acceleration at 5 seconds. Okay, so at 5 seconds, so I don't have paper. Okay, so let's take this paper. 5 seconds. So 5 is between 4 and 6. So look at here, 4 and 6. 4 and 6, object moves from 2 meter to 4 meter. So 4 and 6, object moves from 2 meter to 4 meter. So 2, displacement is 2. So what does that mean? Area is half BH. So 2 is equal to half 2h. Every interval is 2. 6 minus 4 is 2. So this is 2. So velocity is 0 over here. Okay, and the velocity is 2 over here. Velocity is 2 over here. So I'm going to go over here. So 2. I'm going to connect this. If I know the equation of this line, well, I don't need to know the equation of this line. Oh, here, acceleration. I'm finding the acceleration. So I know I need 2 points to do the acceleration. This one gonna become what? This is 2. This is 4. So 4 comma 0. 4 0. This is your x1. This is your y1, and this one is 6 comma negative. Oh, this is positive. Okay, this is positive. This is positive because this is positive. Okay. Okay. I must be tired. So, what time it is? 8:10. Now we're still here. Okay. So this is why this is positive, because this is positive card. So this must be positive. So 4 comma 0, and this is 6 comma 2. 6 comma 2. So this is x2, y2. So y2 minus y1, x2 minus x1. So this is 2 minus 0, and 6 minus 4 is 2. So this is 1. Acceleration is 1. Okay, great. So acceleration is 1. I did not ask you to draw it. I write it. Acceleration 1. Alright, that has been the tutorial for exam 3. Make sure you understand every concept. That's the main purpose of me doing the tutorial, even when I'm tired.